कभी कभी ऐसा भी होता है कि जनरेटिंग फंक्शन दिया हुआ हो और न्यूमेरिक फंक्शन कैलकुलेट करना हो। तो माना लेट जी एक्स इज इक्वल टू 1/12 माइनस 7x प्लस एक्स स्क्वायर। Now the factors are this and the partial fraction becomes this. Taking 3 and 4 in these factors, 1/3, 1 minus x upon 3 power minus 1, 1/4, 1 minus x upon 4 power minus 1. By the help of binomial expansion, we can write these terms as taking x power r as common. Hence, the numeric function have ar is equal to 1/3 power r plus 1 minus 1/4 power r plus 1 with r greater than or equal to 0. Now there is an important note. Let a0, a1, a2 be a numeric function and its generating function ax is equal to summation ar x power r. Now ax upon 1 minus x can be written as this summation can expand a0 plus a1x plus a2x square, or this binomial expansion can be written as 1 plus x square and so on. Now in the multiplication the constant term is a0 and coefficient of x is a0 plus a1 and coefficient of x square will be a0 plus a1 plus a2. Thus we can write this is as summation of x power r a0 plus a1 up to ar, and r goes 0 to infinite. That means summation r 0 to infinite and summation it implies if we divide any generating function with 1 minus x, then we get summation r0 to infinite br x power r, where b0 is equal to a0, b1 is equal to a0 plus a1, b2 is equal to a0 plus a1 plus a2. In this way, we can count the total of 3 terms of this numeric function. We can count the total of 2 terms in this numeric function. Thus, if there is question that find sum 1 square plus 2 square plus 3 square plus dash 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 up to r square, then first we find the generating function of 0 square, 1 square, 2 square, 3 square and so on, which is already known as question. We want to find the total of 1 square, 2 square, 3 square, 4 square up to r square, including with 0 square. That is our question. So as the previous note, if we multiply the generating function this with 1/1 minus x, then we get this, and this is generating function of 0 square, 0 square plus 1 square, 0 square plus 1 square plus 2 square, 0 square plus 1 square plus 2 square plus 3 square, and 0 square plus 1 square plus 2 square up to r square and so on. It implies 0 square plus 1 square plus 2 square plus dash 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 plus r square is equal to coefficient of x power r in x 1 plus x upon 1 minus x cube 1 minus x. Since this is equal to x plus x square, 1 minus x raised to minus 4, and according to binomial expansion, this can be written as, इस ब्रैकेट को ओपन किया, x को मल्टीप्लाई किया x पावर m प्लस 1 और x स्क्वायर को मल्टीप्लाई किया x पावर m प्लस 2. नाउ कोफिशिएंट ऑफ x पावर r इक्वल टू 4 प्लस r minus 1 c r minus 1 plus 4 plus r minus 2 minus 1 c r minus 2. This will be 2 plus r c r minus 1 plus 1 plus r c r minus 2. This will be 2 plus r 1 plus r upon factorial 3, and this will 1 plus r minus 1 upon factorial 3. Taking r plus 1 upon factorial 3 as common, now the remain is 2 plus r minus 1, and our result 6. This is well known, we know that already, that 0 is 1 square plus 2 square 3 square of 2r square is equal to r plus 1 2r plus 1 upon 6. This is our answer. Another question is that in the similar way we can find the total a cube, 2 cube, 3 cube up to r cube. In this question, first we find the generating function corresponding to 0 cube, 1 cube, 2 cube, 3 cube, and multiply corresponding generating function with 1 upon 1 plus x. Find generating function, multiply it with 1 upon 1 minus x, and find coefficient of x raised to r. This will be 1 cube plus 2 cube plus 3 cube up to r cube. Hence we can solve.